Good afternoon, everyone. Welcome back. Yes, good afternoon to Rakshita, Bibu, Sanjay, Sunali, Anand, Rafika, Mohammed, Jia, Diksha, Jyoti, Khushdeep, Nikita, and Surya. Okay, a very good afternoon to all of you. So, today we are going to talk about probability. Okay, and so many of you are asking, so I've incorporated this. The weightage. Okay, so for statistical representation of data, we have all studied frequency distribution, what is a histogram, what is a polygon, what are octaves, what are pie charts. Okay, incidentally, octaves are the cumulative frequency charts. Okay, and then you have measures of central tendencies, mean, median, mode, and all those things that we did up till yesterday that constitute 45 to 50% marks of statistics. And then today what we are going to do is probability, and then today and tomorrow we'll be doing the chapter on probability, and then later on when we are going to do theoretical distribution, that is binomial, Poisson, and a normal distribution, and those will constitute 25 to 30% of your marks. Okay, this file is available on the institute's website also, so you can also refer to this page. Okay, now let us try and understand what is probability. Okay, what do you understand by probability? Some things happen, we are very sure. Okay, and so, but when we are not sure, then we give it a number. Okay, we try to explain it based on what has occurred earlier, or based on statistical information that is available to us. Okay, just like if you feel if you know that a festival is around the corner, the fact the probability that a sweet will be made at home is very high, right? When suppose now we are having Dashera, so when there is Dashera, there will be some sweets in the house, right? That is because based on past experience, you know. Now, when it comes to marks, again, there is a whole statistical issue that can take place. So, for you to understand what statistics is, why we are studying that, and what is probability, this chapter is for you. Now, what does a random experiment mean? What does chance mean? Is that when we are doing an experiment without any pre-decided things, that is known as random experiment. So that we have not rigged anything, like betting, that some matches are already decided and then they are played. No, we are talking about an experiment which is done on its own without anybody doing anything wrong with it. So theory of testing hypothesis and theory of estimation are based on probability. So we are using this chapter on probability to understand the theory of testing hypothesis and testing of estimation. So in hypothesis, like when we are doing an experiment, there are certain things that we assume. For example, if I'm undertaking a study of how many pets each Indian families have. So what sometimes we take a basic hypothesis that most of the Indian families have one pet at least. In that case, this is my hypothesis, and to test that hypothesis, I use probability. Okay, and theory of estimation. The parameters values estimation also is done using probability. Then there are two types of probability, like I was talking about earlier, that is subjective probability and objective probability. Subjective probability, that is personal experience, like mummy making a sweet at home during festival season is from personal experience. Then attitude, then bias and beliefs. Okay, so all these are subjective probabilities, but we are going to in our exam study about objective probability. Is that we conduct an experiment and based on this outcome, we are trying to predict the outcome. It is a performance that produces certain results. For example, when we toss a coin, what will happen? We will either get a heads or we will get a tails, right? So that is an experiment with defined outcomes, right? So in that you have two types of experiments. So which first is the simple and other is the composite or the compound. So simple or elementary and compound or composite. Now what happens in simple? Like I toss a coin. So when I toss a coin, I will get a head or a tail. Okay. Which this is an experiment which we cannot divide further. Okay. That is once I toss, it can either be a head or a tail. I can't do anything about it. Okay. There is nothing else I can do about it. But then if I take two coins and I toss, that is known as a composite or compound experiment. Okay, so tossing of the coin second time will be I toss the first coin and then I toss the second coin. So my experiment can be divided into two parts, that tossing of first coin and then tossing of the second coin. Okay. Then we have concepts called as mutually exclusive events or incompatible events. Yes, Rohini, Divya, Amit, Panchal, Hitendra, Soumya, Garija, Sayed, Pratidnya, Chahal, Chitrang, Sagar, Bhumika, and Shalini also. Good afternoon. Okay. Okay, Bhumika, you are asking what is bias? Bias means that you have a preference of one thing over the other. Okay. So it may be a simple thing like when somebody asks what do you like sweet or savory, then you have a bias towards a savory. So if you are somebody who likes all chatpata foods, then you say you are biased towards chatpata foods. Okay, so that is the meaning of bias. Okay, so you are leaning or preferring one thing over the other. Now, you must know in probability the concepts of mutually exclusive events or incompatible events. That is, in occurrence of one event implies non-occurrence of the other event. Okay, like when I toss a coin, I can get either a head or a tail. I can get both, right? So, occurrence of one event. So, if I get a head, what does it mean? It means I cannot get a tail. Okay, so that is known as mutually exclusive events or incompatible events. Then exhaustive events, the possible set of all possible events, all possible outcomes is known as exhaustive events. Okay, so suppose I am tossing a dice. Okay, so a dice has 1, 2, 3, 4, 5, 6. So once I toss a dice, so all these outcomes, either I get a 1 on the head, either I get 2, 3, 4, 5, 6. This is the exhaustive event for tossing of coins. Okay. Equally likely events, mutually symmetric events, or equally probable events is the third type that we are going to consider, that each event is equally likely to occur. Okay. So if I have an unbiased dice, okay, that is the dice whose center of gravity has not been moved, it is as it should be. So then what happens is it's equally likely event. Okay, so getting any number on the top of the dice is equally likely. I can get a 1, also I can get a 3 also. Both are equally likely. So what are the three things that we are talking about? First is a mutually exclusive event, which says that if one event occurs, the second cannot occur. Second is the exhaustive event, that is a set of all possible events. Third is the equally likely event, is that all probable events have equal probability to occur. Yes, Liza Swati, good afternoon. Now we are talking about the classical definition of probability. If there are n finite simple events which are equally likely to occur, then the probability of event A occurring is given by n of A upon n. What is that? That is number of events favorable to A upon total number of possible events. Okay. So this is the simplest form of definition which says that so which is saying that P of the event A occurring is given by favorable upon total. Okay. This is the simplest possible, or which is called as a classical definition of probability. Okay. So in terms of formula, we write it as n of A upon n, where n is the total number of possible events and n of A is the total number of events which are favorable to A. Then we have what is known as priority definition, which says that P of A is number of mutually exclusive, exhaustive and equally likely events favorable to A. Mutually exclusive, exhaustive and equally likely events favorable to A upon total. Okay. So this is the priori definition which is given by Bernoulli and Laplace. So these have been given by them. So you can get this as a theory question. But as we solve this, you will find that we will be using some concepts of sets and some equations that we learned by learning sets over here. Okay. Now, there is another concept that is important. So, this is the first, that is number of mutually exclusive, exhaustive and equally likely events favorable to A upon total number of mutually exclusive, exhaustive and equally likely event. Now, there is a concept called as expected value. Just take the formula right now. We will be explaining it in detail, which is saying mu is equal to summation x into p. So, P is a probability multiplied by x, that is the event. Then, if I do this multiplication, I will get the expected value. E of x square is equal to summation x square into p. So, this x, when I square it and then when I multiply by p, I get E of x square. Okay, this is E of x, this is E of x square. Then we say that the variance sigma square is equal to E of x square minus mu square. So this is mu. Okay, so I write down mu is equal to summation x into p. Okay, x into p. And then I find out E of x square, which is equal to summation x square into p. And then I say that variance, this I use to find out the standard deviation. So variance is equal to E of x square minus mu square. Okay. And then we find out standard deviation as equal to square root of sigma square. Okay. Have you followed till here? First is we are finding we are understanding what probability is. Probability will be given by number of favorable events upon total number of events. That is first. Then we are talking about expected value. Expected value mu is equal to summation of x into p. Okay. Then we have third is we find out E of x square, which is equal to summation x square into p. Then fourth is we find out variance is equal to E of x square minus mu square. And then we find out the standard deviation. Okay. Bibu? Yes, that is true. Okay, Zeba, you want it again? Okay. See, what happens in composite or compound is that this this event can be broken up into smaller events. Like I said, when I toss 2 coins, it can be broken up into 2 different events. First event is the tossing of the first coin, and then I am tossing the second coin. So that is known as compound or composite. If you remember in 10th, we learned about elements, simple elements and compound elements like water, H2O. Then we talked about hydrogen being a simple element and H2O being a compound. Remember? So similarly, we have that concept over here that if I am able to break or molecule and atom, molecule can be broken down into atoms. So similarly, a composite can be broken down into simple elements or simple events. Okay. Okay, Guru. See, this concepts will be, Guru, clear as we do sums. Okay. Right now, just me trying to tell you what is a mutually exclusive, exhaustive. When I actually do the sums, you will be able to understand it better. See, mutually exclusive events means what? When one event occurs, it automatically means the second is not going to occur. Okay. So when I toss a coin, when I toss a coin and when I get a heads, what does it mean? That tail I cannot get. I have got a head, so I cannot get the tail. So that is implies that non-occurrence, that is all other things will not occur. Exhaustive events is possible. Set of all possible events together is known as the exhaustive event. Exhaust everything, all possible things I have considered, so that is known as exhaustive. Then equally likely events is that each event has equal chance of occurring. If you remember in Mahabharata, Shakuni had changed the center of gravity of the dice. Okay, the dice that he used, that Duryodhan and the Pandavas used to play. Okay, so in that what happened? He used to get the number he wanted. So that is why in that case we cannot say that the events are equally likely. But when I have an unbiased dice, what will happen? I can, and there is equally possible that I can get a 1, I can get a 2, 3, 4, 5, 6. So that is the difference between biased and unbiased. Okay, biased, remember in Mahabharata how Shakuni changed the dice, and unbiased means the normal, like we play in the summer holidays. When we play Ludo, we have that dice. So that is an unbiased dice. Okay, that is the meaning of bias and unbiased. Okay. Mutually exclusive means one event occurring means automatically others cannot occur. Exhaustive means I have considered all possibilities, and equally likely happens when the whole experiment is done in an unbiased way. Okay. These are simple definitions you need to know only for the theory aspect. The sums we are going to do differently. The classical definition of probability says that number of favorable events upon total number of events. Okay. Then we have the priori or the Bernoulli and Laplace definition says number of mutually exclusive, exhaustive and equally likely events in favor of A upon total number of mutually exclusive, exhaustive and equally likely events. Okay. So P of A. Again, this definition emphasizes on unbiased. Second thing is expected value. The formula is mu is equal to summation x into P. Third is E of x square, which is equal to summation x square into P. Fourth is variance, which is sigma square, which is E of x square minus mu square. And fifth is standard deviation, which is square root of variance. Okay. So just hold a little patience as we do the sums. Yes. Yes, Divya understood. I hope, Guru, now you have understood. Abhinav. Hope you have understood, Abhinav. Tossing of the coin. See, if you are watching IPL, so who will bat first? That is decided by tossing of the coin, right? If the coin is unbiased, so every time then India will get to bat. That does not occur, right? Because the coin that is used in the matches is unbiased. So both the teams have equal chance of batting first. So that is known as equally likely events. Okay. Now always remember, okay, this is very important. All these points are very important. The first point you must remember, this is also helpful for you when you're checking your calculation, what you have done. What is the probability value you should get? Your probability should lie between 0 and 1. You cannot get probability value as 1.4 or something, okay? It can be 0 or maximum it can be 1. Otherwise, it is in between, okay? And it cannot be negative also, okay? You can have the probability as 0, but you cannot get it as negative. So if in the calculation you are getting some answer as negative, or if it is getting 1.5 or something above 1, then that means you have taken a wrong formula, or your calculation, there may be some small mistake in your calculation. So check, okay? Second, very important thing, if A is an impossible event, this is a very easy question that you can get for theory. If A is an impossible event, then probability of A occurring is 0. Okay, that is, जो चीज हो ही नहीं सकती उसकी probability कितनी आएगी? उसकी probability 0 आएगी. If A is such a sure event, okay, if A is 100% going to occur, okay, this means what? 0% chance. 0% chance. And if A is a sure event, that P of A equal to 1 means 100% chance. Okay. So 0% chance means it is an impossible event. So P of A is 0. 100% chance that it can occur is, then we say P of A is 1. Then fourth, non-occurrence of event A is denoted by A dash. Remember in set theory also we have done A and A dash. A dash is complement of A, that is P of A dash. Okay. Always remember that P of A, that A is occurring, plus P of A dash, that is A is not occurring, is always equal to 1. P of A and P of A not occurring is always equal to 1. So if P of A is given, now we know the formula for probability of A, that is number of favorable events to A upon total number of events. Then P of A dash, that is P of A not occurring, is 1 minus N of A upon N, which is equal to how much? N minus N of A upon N. Okay. So this is P of A dash. And what happens? P of A plus P of A dash is equal to 1. Okay. Then there are, then you may get questions of odds in favor of A and odds in against A. Now odds in favor of A, so is a ratio, not ratio. It's a ratio of number of favorable events to the number of unfavorable events. Okay. So when we say odds in favor, okay. So when we say that, what are the odds in favor of this event occurring? Then we say that you calculate N of A, then you calculate N minus N of A, and then when you find that ratio, you say it's odds in favor. So odds in favor. If you have seen the exercise, you will see this questions. Odds in favor is given by N of A to N of N minus N of A. Because the favorable thing I have taken first. Now, if I have odds against A, the words is odds against A, that will be, because this is the probability of A occurring, and what is this probability? This is the probability of A not occurring. Okay. So then we have n minus n of A is to n of A. Okay. So this we have talked about the points that you should remember. Okay, these are the properties that you should keep in mind. Okay, I will just repeat them. I'm going very slow, okay, so that all of you have understood. Yes, Zaba understood. Saima, yes, good afternoon, understood. Yes. So, first thing you should remember is, in the calculation, when you get the value of probability, it should lie between 0 and 1. It can be, minimum value can be 0, maximum can be +1. You cannot have a negative value, you cannot have values more than 1. Okay. Second thing is, if A is an impossible event, the probability is equal to 0. When A is an impossible event, the probability of A is 0. Okay. And if the event A is sure to happen, then we say the probability is 1, because 1 is a maximum probability and 0 is a minimum probability. Fourth point is, non-occurrence of event A is denoted by A dash. So what is the probability? Probability of A dash will be 1 minus probability of A occurring. Then we have remember that P of A plus P of A dash will always be equal to 1. Then we have odds in favor and odds against. Now, odds in favor is n of A is to n minus A, n of A. Okay. So, n of A is to n minus n of A. Okay. So, that is odds in favor, and odds against will be n minus n of A is to n of A. Okay. Then we have 3 different things that are being there, that are considered here for you. We are going to deal with examples with coins. We are going to deal with examples with cards. And then we are also going to deal with coins, cards, and dice. Okay, these are the 3 main things that we are going to consider. So let me first give you the basics of how the coin works, what are the formulae that we'll be using over here, and what is the decision tree that we can make for each of these. Let's try to understand this so that when we do the sums, it becomes easier for us, because this concept is already there in your mind. Now the first is coins. Okay. Now what happens when I toss a coin? When I toss a coin, okay. So when I toss a coin, either I can get a head or I get a tail, right? What is the chance of getting a head? So there are 2 possible outcomes. Okay. Exhaustive events are head or tail. So what is the probability that I get a head? The probability of getting a head is equal to 1 upon 2, because there are only 2 outcomes possible. And probability of getting a tail is again 1 upon 2. Okay, this is simple for a single coin. Now I toss 2 coins. So what will happen when I toss 2 coins? So what happens is, first coin, when I toss, either I get a head or I get a tail, right? Then what happens is, after this, when I toss the second coin, what will happen? I can either again get a head or I can get a tail. Same thing happens here. Suppose I got a tail when I toss the first coin. Now I toss the second coin. So what will happen? Again, I can get either a head or a tail. Okay. Now what is the probability of this head? Half. Okay. Because this is one coin, when I toss, I can, probability of getting a head is half. What is the probability of getting a tail? That is also half. Now here, when I toss the second coin, what will happen? Its probability is half. And what is this probability? This probability is also half. What is this probability? Half and half. That is only for the second. But I have already tossed one coin. Okay. I have already tossed one coin. And so I get this half. And after this first event, I am having the second event. Okay. So this is where I must know that this is also half. Then I will get this as 1/4. Then this is 1/4. This is 1/4. And this is 1/4. Okay. Then when I combine, okay, this is 1/2, this is 1/2, this is 1/2, and this is 1/2 individually. But when I consider it the whole thing, this is 1/2 into 1/2, that is 1/4. Then this is also 1/4, this is 1/4, and 1/4. So after I have tossed two coins, what is the possibility that again, after I have tossed two coins, what is the possibility that I get? I can get HH, I can get HT, okay, HH, this H and this H, or HT. Third possibility is TH and TT. TH and TT. Okay. So, what is the probability that I get? Two heads, probability is 1/4. What is the probability I get? HT and TH. Now, can I differentiate? Because the two coins are similar, so I cannot differentiate. So, this 1/4 plus this 1/4 will give me 1/2. And this probability is again 1/4. Now, let me check whether what I have done is correct or not. How do I check it? I check it that I find total probability. Total probability will be equal to 1/4 plus 1/2 plus 1/4. So, 1 plus 2 plus 1, which is equal to 4/4. Haven't I got 1? Yes. That means what I have done is correct. Okay. So I repeat, when I have two coins, when I have a single coin, there is no problem. I get a head and I get a tail, or I get a tail and the probability is 1/2. Okay. Now when I toss two coins, there will be first coin I toss, I will get either a head or a tail. What is the probability? Half and half. Then after that I toss the second coin. What is the probability? I will again get head or tail. But now this first head and the second head is together having a probability of 1/4. Then one head and one tail, the probability of 1/4 and 1/4 becomes 1/2, and probability of getting both tails is also 1/4. And I have also shown you how to cross check. How to cross check. That I added all the probabilities and I got 1. That means whatever I have done is correct. Yes, Chanda, understood? Bhumika, fifth property. Yes, Divya, favorable means what we want. Okay. Yeah. Vibhu, crystal clear. Where did you see M? There is no M, Arshdeep. Arisha. Okay. Guru, this, if you study, all chapters are easy, right? Yes, agar you like the explanation, very good. Okay, peasant, understood? Diksha also understood. Okay, second is A is an impossible event. That is, it cannot occur. then we say the probability is 0. And fifth probability is saying that probability of the event occurring and probability of event not occurring together, the total should always be equal to 1. Okay. Yes, Emma, as we go further, you will be able to understand. Okay. So, and see, as soon as the lecture is over, you can like again see it on YouTube 15-20 minutes, the first 15-20 minutes. So what will happen? All your concepts will again be very clear. Okay. So I am talking about one coin, tossing of one coin and tossing of two coins. Okay. So when I toss one coin, I can either get a head or get a tail. What are the total events? 2. Okay, either getting a head or 2 or tail. So this probability is 1 upon 2. Probability of getting a head is equal to 1 upon 2 and probability of getting a tail is also 1 upon 2. Now when I toss two coins, I can get either a head or a tail of the first coin that I toss. After that has occurred, and then I toss the second coin. So what will happen? Either I get the first coin, I get a head, then there will be a head or a tail. And here you can have a head or a tail. So what does this mean? That means that what is the tossing of two coins? What are the possible outcomes? Possible are HH. Okay, this is this H and this H. That is the first is also an H. First also I get a head. Second time also I get a head. Then second will be TH. That is first is a tail and then a head. Or I can get first a head and then a tail and then two tails. Okay, this is possible. I hope now concept is clear. Now let us talk about 3. So for this example, okay, Ashdeep, I'll just check. Okay, I think there will be some, by mistake, maybe something has been written. Okay, so now what happens is we are tossing the coin 3 times. So what are the possibilities? The possibilities are that I can get, here I have shown you, HTT. That is, I get the head for the first time, then I get a tail, and then again I get a tail. That is 3 coins are there. First coin I toss, I get a head. Next, it is a tail. Another, it is a tail. Then I can get first is a tail, then head, then tail. Then TTH, HHT. So 1, 2, 3, 4, 5, 6, 7, 8. So how many possibilities are there? There are 8 possibilities. Okay. So usually this is going to come in the denominator. This is exhaustive. That when I toss 3 coins, I can get any one of these. I cannot get something out of the other than this. Okay, I cannot get an option other than this. Okay, so HTT, THT, THT, TTH, HHT, and all these are possible. That I can get one head, I can get two heads, or I can get three heads, which automatically implies that I can get one tail, two tails, or three tails. Okay, so these are all the possibilities when I toss a coin. Toss three coins. Now, as we have done for frequency distribution, similarly, I can prepare a probability distribution. So let us see how to prepare a probability distribution. So what is a so I'm trying to make a probability distribution of getting a head. There is a possibility that I get no head, then I get one head, I get two heads, or maximum is three heads. Okay, isn't it maximum? Because three coins are being tossed. Either I get no head, that is all are tails. Either I get one head and two tails. Second is two heads and one tail, or all three are heads. So what is the probability? What is the probability of this getting a head? When there is zero heads, what will happen? What is the probability? This is the only case where there are no heads. TTT is the only case where you have no heads. So this is 1. And what are the total possibilities? 8. So 1 upon 8. What is the favorable event? All three are tails. That is the favorable event, that when I want no heads. So 1 by 8. How many are there with when I have got one head? This is 1. Okay, here I can see one head. Here I can see one head. Here I can see one head. Any other are there? No. So 1, 2, 3. There are 3 possibilities. Out of the 8 possibilities, there are 3 possibilities where I get only one head. So this is written as 3 by 8. Okay. Now what is the possibility I get 2 heads? 2 heads. See, over here you can see 2 heads, 2 heads, and 2 heads. Okay. So 1, 2, and 3. So what is the answer? What is the total probabilities? 8. What are the favorable events? What is the event that I get 2 heads? So what is this? This is 3 by 8, because there are 3 possibilities where I get 2 heads. Now, what is the possibility that all the dice, all the coins have head? First coin I toss, I get a head. Second coin I toss, I get a head. And third coin I toss, again I get a head. So this is the only place where I'm getting head. So that is again 1 by 8. Now I have to check. This all total should come to 1. So 1 by 3 plus 2 by 3, 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, which is equal to 8 upon 8, which is equal to 1. So that my clause that I have, that all probabilities total should be equal to 1, that I have got. Okay. So this is known as the probability distribution table. So what I do, I use this, I see what are the options. What are the options is that I get no head, I get one head, two head, or three head. And that when I write down the probability is what are the favorable events upon total number of events. When 3 coins are tossed, the total number of events is 8. Okay, that is 8 possible outcomes are there. So favorable outcome upon total number of outcomes will give me the probability distribution. Now I can even find the expected value. This is an somewhere all these formula that we have talked about, I am trying to use. What is expected value? Is summation x into p. So this is my x, okay, this is my x and this is my p. I multiply them, okay, I multiply them. So 0 into 0.125. What I have done, I have taken these and converted them into decimal. If you are comfortable with this thing, fractions, you can do it in fractions also, okay. So 1 by 8 is 0.125, 3 by 8 is 0.375 and this total comes to 1. So expected value mu is equal to summation x into p. So 0 into 0.125, 1 into 0.375, then 2 into 0.375, 3 into 0.125, the answer is 1.5. Then I find E of x square, okay. Then I try to find E of x square. So E of x square into p. So what do? I square this. So 0 square is 0. Then 1 square is 1. 2 square is 4. And 3 square is 9. Okay. So 0 square is 0. 1 square is 1. 2 square is 4. And this is 9. So I get E of x square as 9. Okay. So I have found E of x square, which is equal to summation x square into p. Now, why do I need this? This is because I want to find out variance. Variance is equal to E of x square minus mu square. So, this is 3 minus 1.5. This is mu square. Okay. So, what is this 1.5? This is equal to 3 minus 1.5 whole square. 1.5 whole square is 2.25 minus 3. Answer is 0.75. So from this I get variance equal to 0.75 and standard deviation, which is equal to square root of variance, is equal to 0.87. Okay. So tossing of 3 coins, for tossing of 3 coins, I have calculated everything for you. I have shown you how you calculate probability. I have shown you how you can make a probability distribution table. I have shown you how to calculate expected value, then how to find out variance, and then how to find out the standard deviation. Yes, very good, Divya, Sagar. Yeah. Excellent, excellent. Diksha, yes, answer is coming. Yes, very good. Lakshita, 0.75, correct. Divya. Why 0.88? Just check, Divya. Zeba, yes. Okay. So, when I toss 3 coins, first coin, pay attention, Harshdeep. First coin I toss, I get head or tail. Second coin I toss, again I get head or tail. And third coin I toss, again I get head or tail. So when I consider all this, I can see the possibilities that I get 0 heads, 1 head, 2 head, and 3 head. And then I found the probability distribution table, and then I find out the expected value, and then I find the variance, and then I find out the standard deviation. Okay. The second experiment that we have to consider is that for a dice. I am explaining you the whole concept in detail right now, so that once you've understood this concept, while solving the problem, it becomes easy because you've already done the basic work. You've already done that. Now dice. What happens on a dice? On a dice, there are 6 sides. Okay. You know what a dice is? That we use to play Ludo. Okay. So, you may have different numbers on the dice. Okay, so you can have a 1, then 2, then on this 3, 4, and 5 and 6. Okay, so on a dice, you will see that number. Okay, on a dice, you will see the number. or they may even do it through circles, dots. So you may have 1, then you may have 2 and 3 and so on. Okay, this is the way how the dice looks. Now we are trying to see what are the possible outcomes. So now when I toss a single dice, what are the possible outcomes? 1, 2, 3, 4, 5, 6. So for one dice, when I toss, I get 6 outcomes. Then when I toss 2 dice, it will become what? It will become 36. Because for each outcome, I will have 6 again different outcomes. Like in this case, one coin, I had only 2 possibilities, and 2 coins I had it becomes 4. But here what is happening, I already have six outcomes. Okay, when I toss the dice for a first time, it already has 6 outcomes. And then when I toss it again, the second dice, when I toss it, I will get 6 more times. So 6 into 6, so I have 36 possible outcomes. So for that, so the possibilities when 2 dice are tossed is 36. The total of the faces on the dice can be from 2 to 12. Okay, now we are talking about the totals also. So on one dice I get 1, on the other dice I get 1. So 1 plus 1, 2. What are the possibilities? So to get 6, what is the possible combination? Okay, so just pay attention to this, because this I have already done for you. So you can just see and understand. So when I want the total on the 2 dice to be equal to 6, what are the possibilities that I can have? On one dice I can have 1, and on the other dice I can have 5. Then on one dice I have 2, the other dice I should get 4, 3, 3, 4, 2 and 5, 1. Up to 6 I am writing. So the probability that the total on the 2 dices is equal to 6 is given by, this is 1 by 36, 1 by 36, 1 by 36, 1 by 36 and 1 by 36. So 1, 2, 3, 4, 5, that is 5 by 36. Okay. So what is the probability that the total is equal to 6? What are the favorable outcomes? There are 5 favorable outcomes: 1, 5, 2, 4, 3, 3, 4, 2 and 5. What are the favorable outcomes so that the total on the dice is 6 is 1, 2, 3, 4, 5. Those are there 5 possibilities, so 5 upon 36. Now, what is the probability that the total on the 2 coins is equal to 5? That is 1, 2, 3, 4. So I can get 1, 4, I can get 2, 3, or 3, 2 and 4, 1. So that is this. So same thing I have calculated for 4, 3 and 2. What is the minimum value that can be the total on the 2 dice? Is 1 plus 1. Okay. What is the minimum value? 1 plus 1. So that is 2. Okay. Have you understood till 2 to 6, the total? Then we will do 7 to 12. Okay. So what is the minimum total that you can get on 2 dices? 2 is the minimum. And what is the maximum? 6 on one dice and 6 on the other dice. So maximum is 12. So what can be the total on the dice of the 2 dice? It can be 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11, 12. Okay. That is the possibilities, and then you have to find the probabilities for the same. Now to get a 7, how many combination will give me a 7? 1, 6, 2, 5, 3, 4, 4, 3, 5, 2 and 6, 2. 1, 2, 3, 4, 5, 6. Okay. So that is 6. Okay. 7, 8, 9, 10, 11, 12. Okay. So this is how many possibilities are there that I get a total of 12? There is only one possibility, that is 6 and 6. What is the probability that I get the minimum value 1 and 1? There is also 1. So 1 upon 36 is the probability of getting a total of 2. Okay. So for 7 it is 1 by 6, then 8 it is 5 by 36, then it is 4 by 36, 3 by 36, 2 by 36 and 1 by 36. Okay. So this is the possibility. So this is okay. See, the total also comes to 36. So if I total the probability, of all these, so that the sum should come to 1. Okay. If I total the probability, P of 1, total is 2, P of 3, P of 4, P of 5, that is the total on the 2 dices total is 5, P of 6, P of 7, plus P of 8, plus P of 9, plus P of 10, plus P of 11, and plus P of 12. P of 2, what is the probability? 1 by 36. Then P of 3 is how much? 2 by 36. Okay. Plus 2 by 36, plus 3 by 36, 4 by 36, and 5 by 36, up to P of 6. Then 7 will be how much? 1 by 6, then 2 by 6, then 3 by 6, 4 by 6, 5 by 6, and 6 by 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So when I add this, I will get 36 upon 36. Okay, all the denominators are 36, and when I add the numerator, I will get 36 upon 36, which is equal to how much? Which is equal to 1. So that will also tell me that I have exhausted all possibilities I have been able to exhaust. Okay. So first we have talked about what? We have talked about coins. Then now we are talking about dice. That is the possibility. We are considering all the possibilities when 2 dice are tossed. Okay. And we found out the total probability. Now let us move to the cards, and before we try to understand how the playing cards are, what we must consider. Okay, let us take a short break and then we come back and we talk about this. Okay, crystal clear, Zeba Rohini? Yes, very good. Bhumika's understood, Sagar understood. Yes, maximum is 12. Okay, Diksha, easy? Yeah, very good. Okay, yes, Sayed. Correct. So let us take a short break and then when we come back, we talk about cards. Welcome back. We are discussing probability, and in probability we are discussing three types of sums that we encounter in our syllabus. The first type we are talking about is tossing of coins. Then we have discussed about tossing of dice, and then now we are going to talk about cards. Okay, playing cards. If you have seen playing cards, there are four sets. In one set there are four possibilities. One is hearts, then diamond, then club and spades. Okay, तो जो खेलने के ताश के पत्ते होते हैं उसके बारे में होता है. तो उसमें आपका हार्ट्स माने बादाम, स्पेड्स माने इस्पिक, डायमंड्स माने डायमंड्स और क्लब्स माने किल्वर. तो इन चार जो होते हैं दोज आर कॉल्ड एज कार्ड्स. ओके, प्लेइंग कार्ड्स यानी ताश के पत्ते. इन देम व्हाट यू हैव 13 of each. Okay, you have 13 of hearts, 13 cards of spades, 13 cards of diamonds and 13 cards of clubs. Okay, in those 13 cards you have numbers 1 to 10. Okay, 1 is known as ace. Okay, 1 is known as ace, is the ace. Okay, then you have three picture cards. Three picture cards, which are the jack, queen and king. एस माने इक्का, पिक्चर कार्ड्स मतलब जो क्वीन, रानी, राजा और गुलाम रहता है वो आपके पिक्चर कार्ड्स हो गए. ओके, सो the number 1 card is the ace. Then you have three picture cards, jack, queen and king. So there are 4 aces in one set of cards. There are 4 aces, 4 jacks, 4 queens and 4 kings. Okay, total picture cards will be 12. So this is 4, 4, 4 and 4. So this is ace, and this jack, queen and king, these are picture cards, and the total is 12. Okay, so cards are numbered from ace 2, 3 up to 10, and then you have the jack, queen and king. So total cards, total number of cards for each deck is for each type is 13. And in one deck, how many? So you may get in the question deck of cards. Deck of cards means all those 52. There are 52 cards in a deck of cards, out of which 13 are hearts, 13 are spades, 13 are diamonds and 13 are clubs. Okay. So what is the probability that you get an ace, or what is the probability that you get a king, queen or jack? So what is the probability? 4 upon 52. Okay, the probability of all this is equal because how many aces are there? There are 4 aces, so 4 upon 52. How many kings are there? 4, so 4 upon 52. Okay, so this is in the ratio and this is in the form of decimals. Then what is the probability of getting a spade, or where we are not considering whether it's a picture card or a number card? Okay, we're just considering that the color. Okay, so if it is the color and the type is a spade, then we say it is equal. That is, probability of getting a spade is equal to probability of getting a heart, diamond and club is 13 by 52. Because for one type there are 13 cards. So 13 upon 52. Then what is the probability that you have a king of spade? How many kings of spade do you have in a deck of card? Only one, right? You only have one king of spade. आपके पास इस पिक के इक्के कितने होंगे? एक होगा, तो 52 पत्तों में से एक होगा, तो 1 upon 52. Okay, so king of heart, king of spade, so all this is equal to 1 upon 52. Also there is one remaining. What is the probability of getting a black card? Okay, what is the probability of getting a black card? How many black cards are there? 13 of spade and 13 of clubs. किलवर के 13 पत्ते और इस पे के 13 पत्ते कितने हो गए 26. So that is 26 upon 52. So that is equal to half. Okay. So in a deck of cards, there you will have 26 black and 26 colored cards. So the probability of getting a red card is again 26 upon 52, which is equal to half. So for a deck of cards, okay, I'm repeating. For a deck of cards, I can get 13 hearts, 13 spades, 13 diamonds, and 13 clubs. Of them, 4 are aces, so 4 are jacks, 4 are queens, and 4 are kings. What is the probability of getting a ace? It is equal to 4 upon 52. What is the probability of getting a king? It is again 4 upon 52. What is the probability of getting a spade card? It will be 13 upon 52. Okay. So these are the basic information when you're dealing with some cards you should know of. Okay. Understood till now? Yes, very good, Tejashri. Yes. Lakshita, what is the probability of getting an ace? Any ace. So there are 4 aces in the deck of cards, right? Ace of spade, ace of club, ace of diamonds, and ace of hearts. So there are 4 aces. So what is the probability of getting an ace? We are not specifying it has to be ace of club. No, we just want an ace. So what is the probability of getting an ace? It is 4 upon 52. Clear? Yes, Divya, correct. Zeba, yes. Rohini also is understood. Very good. Lakshita, it is not 4, 4, 4, 1. There are 4 of clubs. Okay. So you will get 4. There is 1 ace for each type of card. Yes, Sagar? Bhargavi? Yes, Diksha? Correct. So, a coin is tossed 3 times. What is the probability of getting 2 heads? At least 2 heads. Okay. So, we know when we toss a coin 3 times, what is the possibilities? H, T, T, H, T, H. Okay, let me write them order wise. It becomes easier. Just a minute. HTT, that is the first coin toss gets a head, then T, then a tail and a tail. Then you can have T, H, T or T, T, H. Okay. Then what is the possibility? I can get 2 heads. So H, H, T, T, H, H or H, T, H. Okay. Then there is a possibility of getting 3 heads. So that will be H, H, H. Then there is a possibility of getting 0 heads. So that is T, T, T. Okay. So these are the 8 possible outcomes when I toss 3 coins. So what is the probability of getting 2 heads? So where are the 2 heads? Okay, this 1, 2 and 3. So out of 8, I am getting 3 heads here. So probability of getting 2 heads, 2 heads is, what is the probability n of favorable events? What is the favorable event that I am getting 2 heads upon total number of events. So 1, 2, 3, 4, 5, 6, 7, 8. So denominator is 8. There are 8 possibilities. And what are the number of favorable events? 1, 2 and 3. So 3 by 8. So what is the answer? 3 divided by 8, the answer is 0.375. Okay. So they may give 3 by 8 as the option, or they may give you 0.375 as an option. Okay. So here, whenever the such type of questions comes, write down all the possibilities, and then you will be able to write down the probability. Now, second is at least 2 heads. At least 2 heads means what? I can this is equal to P of 2 heads plus P of 2 heads plus P of 3 heads. Okay, at least. The word at least is very important. So in probability, you have to just pay minute attention to what the words are saying. Okay, what is the possibilities? 2 heads are 1, 2, and 3. And what is 3 heads? This one also. Okay, this is also there. So this will be P of 2 heads. That is 3 by 8. What is the probability of getting 3 heads? 1 by 8. And what is the total probability? 4 upon 8, which is equal to half, which is equal to 0.50. Okay. So this is how you have to do the sum. Okay. Now I want to revise something of the sets. So when we are talking of OR, then union, and then AND, like in the set theory, we have talked about OR, union, intersection, and AND. So all those concepts, and I want to revise this formula. You remember remember the formula here? Okay, we have done N of A union B is equal to N of A plus N of B plus N of A, minus. Minus N of A intersection B. Okay. So same thing, we use it for probability also. P of A union B is equal to P of A plus P of B minus P of A intersection B. Then conditional probability also P of B given A has occurred. P of B given A has occurred is equal to P of A intersection B upon P of A. This is the conditional probability. Then similarly also you can have P of A given B will be equal to P of A intersection B upon P of B. Okay. P of A intersection B upon P of B. Then P of A intersection B will be equal to. Then I can also cross multiply and get this. Okay. So I have P of B given A is equal to P of A intersection B upon P of A. Okay. So P of A intersection B will be equal to P of A into P of B given A. Okay. So same thing I've written P of B of A into P of A. Okay. So just one formula I use and then I can get the other formula also. This first formula, there is no problem. We've already done and said P of A union B will be equal to P of A plus P of B minus P of A intersection B. Second is P of B given A is P of A intersection B upon P of A. Third formula I'm talking about is, which is an offshoot of this formula, the P of A intersection B is equal to P of A given P of B given A into P of A. Then you also have this fourth formula, P of A minus B plus P of B minus A. Remember, this is not A and B minus of a number, but what are the remember in sets we have done, what are the events that are present in A but not in B? When we talked about sets, we talked about numbers. What are the numbers which are there in A and not in B? So that is P of that is A minus B, and P of B minus A is what are the numbers which are there in B but not in A. Those of you who don't remember, please go back to the set videos of on set and set theory, and then you can just revise that. Just look, go through that video, and then you will be able to understand. B minus A is what are the elements in B which are not there in A. What is A minus B? What are the elements in A which are not in B? Is A minus B equal to B minus A? No. A minus B is different and B minus A is different. Okay. So probability of A minus B plus B minus A is equal to probability of A plus probability of B minus 2 times probability of A intersection B. Okay. And expected frequency is N star P of A union B. Okay, this formula we'll be doing tomorrow. So, but you must know this formula. So I've written it in one place so that you are able to understand them. Okay, so this all have been derived from the set theory. So P of B given A is P of A intersection B upon P of A, and expected frequency also N into P of A union B. Manvi, by next month, your syllabus will be completed. Yes, Bhumika, right? Yes, Gunjan, heart and diamond are red colored. Heart मतलब बादाम के पत्ते, diamond मतलब क्या बोलते हैं उसको? Chocolate. So badam and chocolate are red colored, and spick और किलवर जो होते हैं वो आपके क्लब और स्पेड जो होते हैं वो काले रंग के होते हैं. So there are 2 colors in cards, black and red. Excellent, Vaishnav. Excellent. Sagar, yes. Simon, last one. Which one? This one you want? Okay. So these are formulas, and if not understood, just make sure that you revise the set. This is for all of you. Just whenever you want to study probability, revise the chapter on sets. Then it becomes easier for you. Just half an hour, you just go through all the set sums that we have solved, and once you do that, you will be finding this very easy. So what is the P of A union B is P of A plus P of B minus P of A intersection B. The second is P of B given A is P of A intersection B upon P of A. And similar formula we have for P of A given B, which is equal to P of A intersection B upon P of B. Then we have P of A intersection B to be this formula again. I have just changed the sides and I'm getting this. P of A intersection B is equal to P of B given A into P of A. And then we have this very unique formula. So P of this they sometimes ask you in the theory question also. P of A minus B plus P of B minus A is equal to how much? P of A plus P of B minus 2 times P of A intersection B. And expected frequency, tomorrow when we'll be doing sums on this, you will be able to understand P of expected frequency is equal to N into P of A union B. Now, what is mutually exclusive events? And mutually exhaustive events and events equally likely. What we studied in the theory at the start of the session, we're going to try to put a formula to it. Mutually exclusive events means when one thing happens, the other cannot happen. And so what will be the intersection? Intersection means A is also happening and B is also happening. What is the possibility for mutually exclusive event? It is a null set. It is a null set. There will be no possible outcomes where both are occurring because they are mutually exclusive. Like when I toss a coin, Is it possible to get one, when I'm tossing just one coin, is it possible to get a head as well as a tail? No. What is the possibility? Zero. Okay. Either I can get a head or I can get a tail. I cannot get something in between. So the P of A intersection B is 0. Then what is the formula for P of A union B? I'll just write it over here. P of A plus P of B minus P of A intersection B. Now what is happening to P of A intersection B? It is 0. It's a null set. So this probability is 0. So we have this formula. You don't have to learn all these formula. You just have to remember what the concept is. You must remember this formula. This is very important. P of A union B is equal to P of A plus P of B minus P of A intersection B. So for that, what happens when you have mutually exclusive event? P of A intersection B becomes null set. So whatever will be its probability, it will become 0. And so P of A union B will be P of A plus P of B. Now mutually exhaustive event means all possible things I have considered. So what will be its probability? Its probability will be 1. For example, in the tossing of two coins, this is my sample space. Okay, this is my sample space. So what is the probability of getting the sample space? How many possibilities are there? 8. What is the total number of possibilities? 8. 8 upon 8. So probability is 1. Okay. So we are saying that mutually exhaustive event means there cannot be any other possibility. All possibilities you have considered, the probability is 1. Means what? At least one of them has to occur. So probability is 1. Events are equally likely is that P of A is equal to P of B. Whenever you hear the words probability events are equally likely, then P of A is equal to P of B. So mutually exclusive events means what? P of A union B is equal to P of A plus P of B. Mutually exhaustive events is P of A union B is equal to 1. Events are equally likely, P of A is equal to P of B. Okay. Okay. Mutually exclusive events means what? P of A union B is equal to P of A plus P of B. Now you can understand this easily. Exhaustive event probability is equal to 1. Equally likely, P of A is equal to P of B. Okay, clear? Okay, so now let us consider this tossing of a coin, single coin. So what is the possible outcomes that I can get? I can get on the top of the not coin, this is dice, sorry. Tossing of a dice. Okay. Tossing of dice when I do, what is the possibilities? 1, 2, 3, 4, 5, 6. Now I just want to show you here. So what will be set A? Okay. X is such that X is an even number of points in S. What are even among this? Which are the numbers even among this? Can you put it in the chat box? Which are the numbers which are even? Can you tell me what will be the elements of set A, set B and set C? Can anybody tell me? X is an even number of points. In this S, that is 1, 2, 3, 4, 5, 6. Which of them is even? Then B is, what is the odd? C is, number is a multiple of 3. Wow, so many answers. Great. Tejashri, Arisha, Vaishnav, Rohini, Jia, Zeba, Ashdeep, Soumya, Devesh, Sonali, Divya, Vibhu, Lakshita, Bala, Soumya. Yes, Soumya has given the next answer also. So here even is 2, 4, 6. Odd is 1, 3, 5. And multiples of 3. Which are the numbers which we can divide by 3? So, excellent, excellent. Tanu, yes. Said? Yes, Bhumika, Rohan, yeah. This is 3 and 6. Now what do I need to find out? I need to find out A intersection B. A intersection B means what? What is the, okay, what are the numbers which are common to both A and B? Are there any numbers common to A and B? So that is a null set. Then you have A intersection C. A intersection C. Any numbers which are common to A and C? Yes, the number 6 is common to A and C. A union B. Okay, what will be A union B? All these numbers. So 1, 2, 3, 4, 5 and 6. Okay, A union B. What is A union C? A union C is how much? A union C. So 2, 3, 4, 6. Okay. A minus B. A minus B. So which are the numbers which are there in A but not in B? Which are the numbers which are present in A but not in B? That is 2, 4, 6. All the numbers are present in A but they are not present in B. Then you have A minus C. A minus C. So 2, 4. Because 6 is common. So A minus C, it will be 2, 4. What is the probability of A union B? What is the probability of A union B? It is, how many elements are there? 1, 2, 3, 4, 5, 6. So 6 upon, what is the total number of elements? 1, 2, 3, 4, 5, 6. So 6 upon 6, answer is 1. What is the probability of A union B union C? How many elements will be there in A union B union C? 1, 2, 3, 4, 5, 6. So it will be 6 upon 6. Answer is 1. Okay. This is just a revision of the set theory I have done so that we will be now moving towards the exercise. We have talked about coins. We have talked about dice. We have talked about playing cards. And so now we are doing sums based on those concepts we are doing. Now we are talking about choosing of balls. Okay. 2 balls are drawn from a bag containing 5 white. So I'll just write down 5 white and 7 black balls at random. So what are the total number of balls? Total number of balls is equal to 12. What is the probability that they would be of different colors? Okay. So I'm drawing 2 balls. I'm drawing 2 balls. So what is the probability? That the first is a white ball and the second is a black ball. Second possibility is what? First is a black ball, second is a white ball. Okay, so first is white, second is black. So what is the possibility of getting a white ball? This is the total number of balls is 12. How many white do I have? 5 upon 12. Now what will be the probability of getting a black ball? Black will be how much? Now out of these 12 balls, I have already chosen 1 ball. How many balls will remain? 11. So denominator becomes 11. Okay. This is crucial that you remember. Out of 12 balls, I have already taken out 1. So remaining 11 balls. Out of the remaining 11 balls, how many are black balls? 7 are black because I have already chosen 1 white. But then the 7 black balls are still remaining. So this is equal to 35 upon 132. Now let us consider the other option that I have. That first ball is black. How many black balls are there? 7. How many total balls are there? 12. Okay. After that, I have taken out one ball. How many will remain? 11. How many of these 11 will be red? This will be white. This will be 5. So this is 35 upon 132. So what is the possibility? So probability that balls are of different colors are of different colors will be equal to 35 upon 132. That is this first one. And 35 upon 132. That is the second one, which is equal to 70 upon 132. So this is 2. 35 is a 266. Okay, 35 upon 66. So A will be the correct answer. Okay. So this is how you will do the first sum. I hope you've understood. Yes, correct, Sagar, Bhumika. Yes, Diksha. Jyoti, it is the exercise. I don't know the page number. Ashdeep, out of 12 balls, you've already taken out one ball. So how many balls will remain? 11, no? 12 minus 1 is 11. Yes, Rohini. Okay. Now, second question. What is the chance of throwing at least 7 in a single cast with 2 dice? At least 7 in a single cast of 2 dice. Means what? The total of it should come to at least 7. Okay. Now, what does it mean? That is, the total can be 7, 8, 9, 10, 11, 12. Okay. So, instead of doing that, what we do is probability of getting at least 7 is equal to 1 minus probability of getting up to 6. Okay. So, probability of getting up to 6. So, if I subtract this, then what will happen? That what will remain will be that the sum is more than 6. That is 7 up to 12. Okay. Now, let us see this. Now, which is represented by 1 minus probability of is that it is less than or equal to 6. Now, let us see. Which are the possibilities that I have? First possibility is 1, 1. In both the dice, I am getting 1 and 1. Then, on one dice, it is 1. Then 2, 1, 3, 1, 4, and 1, 5. Okay. Then, 2, 1, 2, 2, 2, 3. Okay. Because if I take 2, 4, what will happen? Yes, I can take 2, 4 also. But I can't take 2, 5 because it will be 7 or greater than 7. We are considering what? P of less than 6. The total should be less than 6. So, we are considering the outcomes. Then I can have 3, 1 and 3, 2, 3, 1, 3, 2 and 3, 3. Okay. So, this is maximum. Total is up to 6. Then 4, 1 and 4, 2. Then 5, 1. Can I go to 6? No, because 6, 1, total will be 7. So, what are the outcomes when the total is less than or equal to 6? These are the possible outcomes. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So, how many are there? 15. And what is the total number? total number will be 36. When I am tossing two coins, what are the possibilities? 36 possibilities are there. So that what we have here is this is equal to 1 minus, these are 15. So 15 upon 36. What are the total possibilities? When you toss two coins, there are 36 possibilities. Out of that, 15 are such that the total on the two dice will be less than or equal to 6. So this is equal to 36 is, that is 21 upon 36. 7 3 7s are 3 12s. So answer is 7 upon 12. So B will be the correct answer. Okay. So third, what is the chance of getting at least one defective item if 3 items are drawn randomly from a lot containing 6 items, out of which 3 are defective? So I have 6 items. Out of that, 2 are defective. So what does that mean? 4 are non-defective, right? Out of 6 items, if 2 are defective, how many non-defective will be? I will have 4 non-defective. What is the chance of getting at least one defective items if 3 items are drawn randomly from a lot containing 6? At least one defective. At least one defective, probability of at least one defective is equal to, probability is equal to 1 minus probability of getting 0 defects. Okay. Once I eliminate 0 defect, what will happen? All the other options will have at least one defect. Okay. So what is P of 0 defect? So which is equal to probability of 1 minus. That means what should I do? I should choose from these 4 non-defective items. Out of the 6 items, if I choose from the 4 non-defective items, what will happen? What choice I have will have 0 defect. So that is 4 upon 6. Okay. So okay, just let me show you separately. I don't want to confuse you. So we will first talk about 0 defects. So we are talking about P of 0 defect. So when I'm talking of P of 0 defect, what will happen here is 4 upon 6. Okay. So out of this 4, out of this 6, and we have drawn how many? 3 items. Okay. So first item I draw out of the 6 items. I have an option of 4 items which are non-defective. So 4 upon 6. Then what will happen? How many items will will remain with me? 5, because out of 5 I have already chosen 1. So how many will remain? 5. Okay. Actually pay attention that out of 6 items I have already taken out 1. So remaining items are 5. Out of these 5, how many are non-defective? Because there were 4 non-defective, but I've already chosen 1. So there will be 3 non-defectives. Then after 2 items have been chosen, how many items will remain? 4. Out of these 4, how many will be non-defective? 2. Because there were total 4 non-defective items. Out of the 4 non-defective items, I've chosen first, then second, and now third. So how much is this probability? 4 upon 6 into 3 upon 5 into 2 upon 4. So this is so 4 will cancel with this 4, 3 and this 2 will cancel with this. So answer is 1 upon 5. Okay, answer is. So what is the probability of getting a 0 defect? It is 1 upon 5. So P of at least one defect will be equal to 1 minus P of 0 defect. What is this probability? 1 upon 5. So this is 1 minus 1 upon 5. So which is equal to 4 upon 5. Okay. Cross multiply 5 minus 1 is 4 upon 5. Okay. So which is, they are in decimal. So this is 0.80. 4 upon 5 is 0.8. Okay. So this is how you have to calculate for this thing. At least one defect. If two unbiased dice are rolled together, what is the probability of getting no difference? No difference. When will you get no difference when you are rolling dice? When on both the tops you are getting the same number. Okay, when on both the tops you are getting the same number. So no difference means same number on top. Okay. So what are the possibilities? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Okay. 1, 2, 3, 4, 5, 6. When you get this option, then the difference is 0. How many are there? 6. And what are the total space that you have? That is 36. Okay, there are 36 possible outcomes, and out of this 36 possible outcomes, in how many outcomes do you find the difference to be equal to 0? Okay, no difference means difference is 0. It is 6. So probability of no difference is equal to 6 upon 36, which is equal to 1 upon 6. So D will be the correct answer. Okay. So far so good. Vinodini, first sum. Okay. Jia, very good. Yeah, we are doing sums. Let me just take that also. Okay. Don't worry. So here I will write it for all of you who have not understood where we got the 11 balls. We had, what are the balls? 12 balls. Out of them, I took one ball. How many will remain? Out of 12 balls, I've taken one ball. How many will remain? 11 balls. So when I'm choosing the second ball, I have 11 balls only. So that 11 will come in the denominator. Okay, is that clear? Okay, so therefore you get 11. In the second sum, what we need to find out? We need to find out when will you get the total as 7 more, at least 7. So at least 7 means what? You have 7, 8, 9, 10. Whenever you get problems of at least 7, it is always better to use this type of sum. 1 minus B of P up to 6. Okay, so more than 7 means I take less than 7, that is up from 0 up to 6. So what will happen here is I will get this possibilities. I find out when will the total be up to 6. Okay, 6 or less than 6. So I find out all the options when the total is up to 6. That is, so first possibility is 1, 1. 2, 1, 2, 1, 3, 1, 4, and 1, 5. So that on one dice I get a 1. What is the what are the other point? What is the point I can get on the other dice? So I can get 1, 2, 3, 4, 5. But if on my dice I get 2, first dice I get 2, what is the number I can get on the other dice is 1, 2, 3, 4. This is for the condition to be met is P of the total should be equal to maximum equal to 6. Okay. In the third question, what are we doing? We have 6 items total. Out of them, 4 are defective. If out of 6, 2 are defective, then how many will be non-defective? 4 will be non-defective. So out of 6 items, 2 are defective. So I've written 2 is defective here and 4 will be non-defective. Now I must find out at least one defective. At least one defective means if I find out when there is no defect and I subtract it from 1, I will get the probability of non-defective. Of at least one defective. So when I'm talking of 0 defect, so here also same thing. First, out of 6 balls, I chose one ball. So 5 remain. Okay. Then out of the 5, I chose 1 ball. So 5 minus 1, 4 remain. Okay. So this is where you have a 6 here, you have a 5 here, and you have a 4 here. Okay. Understood? Then here, simple thing, we took 2 unbiased dices, we rolled them together, we found out under which conditions we will have same on the top. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So here you can do. Can you use the same method here? Yes, you can do it, but it will become a huge, you'll need a huge place to write down all the possibilities. So it is better you do it this way. This is very important. If you can remember this, how you can do this is P of getting at least one defect means P of 1 minus P of no defect. P of A, B, and C are mutually exclusive, independent, and exhaustive events. Okay. So this is a very interesting question. So pay attention. If A, B, and C are mutually exclusive, means what? When one occurs, another cannot occur. Independent. So it is one is not dependent on another happening. And exhaustive events. Then what is the probability that they occur simultaneously? So you have mutually exclusive, mutually independent, and exhaustive. So in all these cases, what will happen? What I can give you a simple example that you have morning, afternoon, and evening in a day, right? Can you tell me a time in the day when it is morning as well as evening? Do you have such a thing happening? So that means what? They are exclusive. Okay. One and the other cannot happen together and they are independent. Having a morning is independent of having an evening. So mutually exclusive, independent, and exhaustive, so that you cannot have a afternoon and an evening together or a morning and an evening together. So we are saying they are mutually exclusive, independent, and exhaustive. So what is the possibility of that happening? This is equal to 0. Okay. Why? Because you cannot have all three together at one time. You cannot have morning, evening, and afternoon at the same time. So this is 0. Lakshita, it is written 2 balls are drawn from a bag containing 5 white and 7 balls. So when you are drawing 2 balls, first you pick up 1 ball and then you pick up the second ball. Okay. So it is already written. Okay. So 2 is written over here. 2 balls. So you take one, you see the color, keep it aside. Then you put your hand in the bag. You take out another. Okay. And then you see the color. So that is the concept here. So once I've taken one ball out of 12 balls, 11 will remain. And out of that 11, I will take out one more. Okay. Yes, Ardhendu. Thank you. Yes, Vaishnav, very good. Yes, Bhumika. View, yes. Yes, Abhinav, very good. Now you got confident. You are saying you will do the sums on your own. Very nice. Next sum you do on your own and let me know the answer. Yes, very good. I'm so happy when that happens. Okay. Now, yes, now you can tell me the answer here. There are 10 balls numbered 1 to 10 in a box. If one of them is selected at random, what is the probability that the number printed on the ball would be an odd number greater than 4? Okay. Odd number greater than 4. So you have a bag or you have a box and you put in balls over there. When you put in the ball, you just number those balls. How many balls are there? 10. So you write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what happens is you're just selecting one ball at random. Okay. You just put your hand inside the box without looking and then you pull out that ball. They want you to find out what is the probability that the ball that you have selected is greater than 4 and it is an odd number. So, number of balls in the box are 10. Then number of balls, and that is not right number. Then balls in the box which have a number greater than 10, greater than 4 and is an odd number. Okay. Will be equal to, let us see. Greater than 4 means we start with 5. Is 5 an odd number and greater than 4? Yes, 5. 6 is an even number. Then we have 7. 8 we cannot write. Then we write 9. 10 we don't write. 11. No, we don't have 10. You have only 10 balls. So 5, 7 and 9. So the balls numbered 5, 7 and 9. So how many balls are there? 3 balls are there. What is the total? Total number of balls? 10. And how much is this? This is n of balls with number greater than 4 and odd is 3. So what is the probability? Probability will be equal to 3 upon 10, which is equal to 0.30. Answer is D. Okay, let us take this 7th sum. Yes, excellent, Zeba, Bhumika, Ardhendu, Vaishnav, Manshi. Yes, very nice, very nice. Lakshita, where did you get this? Okay, just follow what I have done. You'll be able to find out. Following are the wages of 8 workers in rupees. If one of the workers is selected at random, what is the probability that his wage would be lower than the average wage? Okay. So this is a sum in which central tendency and probability is coming into picture. So first I need to find out average wage. Average wage of workers. What is the formula? Summation x upon n. So what are the numbers? What are the wages? 50 plus 62 plus 40 plus 70 plus 45 plus 56 plus 32 plus 45 upon how many numbers are there? 8. 1, 2, 3, 4, 5, 6, 7, 8. So can you find me the average? Okay, what is the average? Yes. Average is 50. Rohan, thank you. So average is 50. Now they are saying lower than 50. Which of these people have wage lower than 50? This is equal to 50. 62 no. Yes. 40 is one. 72 no. 45 is another. 50 no. This is there. 32 and 45. How many are there? 1, 2, 3, 4. How many are total? So probability that wage is less than average. How many people are there? 1, 2, 3, 4. What are the total number of people? 8. So 4 upon 8 is 0.50. So B will be the correct answer. Okay. So we stop here for today. And then tomorrow we'll complete these sums and then we'll go to the base theorem also. Okay. Yes. Thank you for your patient hearing. Have a great day ahead. Yes, Bhumika. Yes, correct. Yes, Tejasri, correct. Vinu?